In early 1943, across the vast airfields of Kansas, California, and Georgia, the mighty B-29 Superfortress stood gleaming in the sun, the most expensive aircraft ever built at the time. Designed to carry war across the Pacific, it symbolized America's technological power, yet inside hangars, the atmosphere was anything but confident. Ground crews whispered of engines that overheated within minutes of takeoff, of flames licking nacelles before aircraft even left the runway. The Wright R-3350 duplex Cyclone engine, a 2,200 horsepower masterpiece on paper, had become a death trap in practice. Pilots called it the four-engine funeral, and mechanics feared the next test flight might be their last. At Wright Field in Dayton, engineers studied melted pistons, burned oil lines, and warped cowlings, unable to understand why the airflow around the massive engines turned turbulent. Every configuration, open cowls, modified vents, new baffles, seemed to worsen the problem. The Army Air Forces poured millions into solutions, but each failure brought new despair. With war production ramping up and Japan's defenses growing stronger, the B-29's reliability crisis threatened to cripple America's strategic bombing plans before they began. In Cleveland, Ohio, thousands of miles from military laboratories, an entirely different kind of problem solver read about the disasters in a local newspaper. His name was Tony Validore, a plumber by trade, with hands hardened from years of fitting copper and steel under pressure. He had once repaired industrial cooling lines for automotive plants and understood the behavior of air and liquid inside confined spaces better than most engineers who held degrees. The idea that hot air could be redirected the same way as water through pipes fascinated him. To Validore, the overheating problem was not mechanical. It was a matter of circulation. He began sketching crude diagrams on scrap paper at his kitchen table, tracing airflow paths through makeshift ductwork. His wife, uncertain but supportive, watched him saw and solder pieces of aluminum tubing scavenged from junkyards. Within days, he assembled a prototype that could redirect hot air around the engine block, venting heat before it reached ignition levels. It was untested, unsanctioned, and by military standards, ridiculous. Yet, in that cluttered basement workshop, a seventh-grade educated plumber was about to solve what America's best engineers could not. In the winter of 1943, Tony Validore's basement workshop glowed with the flicker of a single hanging bulb, illuminating aluminum scraps, rusted fittings, and a battered plumber's torch. The faint hiss of steam filled the room as he tested his improvised design, which resembled more a jumble of pipes than an aviation component. His concept was simple yet daring. Create a bypass airflow system that redirected excess heat away from the engine, cylinders, before ignition temperatures could cause a fire. Using principles he'd learned from plumbing boilers, Tony calculated that if he could balance airflow between hot and cold zones, he could stabilize engine temperatures without altering the engine itself. He attached small aluminum tubes to simulate air channels, then used a household fan to mimic propeller wash. To his amazement, the thermometer on his workbench dropped rapidly, showing a 100-degree difference between the inlet and exhaust sections. The airflow equalized, just as water did when rerouted through balanced piping. What high-paid aeronautical engineers had dismissed as thermodynamic chaos now behaved like the plumbing systems Tony repaired every day. The problem wasn't power or fuel, it was flow, pure and simple. Encouraged, he refined the design, replacing his crude bends with smoother elbows, experimenting with varying diameters, and measuring velocity through each duct. Over weeks of trial, his humble system transformed into an elegant, functional model of balanced cooling. Still, he knew no one in authority would take a plumber seriously. The Army Air Forces employed legions of scientists, and each worked under the strict hierarchy of military engineering. For a civilian mechanic with a seventh-grade education to claim he solved their crisis bordered on madness. Yet Tony's conviction was immovable. He spent his savings to construct a full-scale mock-up using scrap aluminum from a Cleveland factory that produced aircraft panels. When finished, it weighed under 30 pounds and required no special tools to install, a portable solution that any crewman could attach in the field. Standing over the completed unit, Tony realized his idea had crossed from imagination into tangible reality. All he needed now was someone willing to listen, someone who believed that a Plumber's pipes could save America's most advanced bomber from its own fire. By March 1943, Tony Validore carried his strange aluminum assembly into Wright Field in Dayton, Ohio, the center of American aeronautical testing. The hangars buzzed with military personnel, engineers in white coats, and mechanics rushing between engines suspended on steel mounts. His invention, wrapped in burlap and tied with rope, looked nothing like official equipment. When the guards at the entrance asked for clearance, Tony hesitated, admitting he had none. Moments later, an officer escorted him toward the engineering offices, not to welcome him, but to question his purpose on restricted grounds. Inside a room lined with blueprints and smoking ashtrays, Tony unfolded his pipe contraption before a circle of skeptical engineers. Their chief, Major Harold Lytle, examined the strange curves and connectors with faint amusement. "You're telling me," he said dryly, "that plumbing can fix aerodynamics?" Tony nodded without hesitation, explaining how trapped air behind the B-29's cowlings behaved like water in a blocked line. His analogy drew chuckles, but when he produced temperature charts from his basement tests, the laughter faded. The readings showed a consistent drop exceeding 100 degrees Fahrenheit, a claim so precise it demanded verification. Still, military procedure required approval from multiple divisions before any new part could be tested. Weeks passed as Tony waited for authorization, sleeping in his truck near the airfield gates. Some officers advised him to go home, others quietly admired his persistence. Finally, word arrived. His device would be tested on a ground engine under controlled conditions. On a brisk April morning, Tony stood beside the massive Wright R-3350 as technicians installed his piping network, weaving it around the cylinders like veins around a heart. When the engine roared to life, the temperature gauges began their slow climb. Tony watched in silence, gripping his wrench. At 2,000 revolutions per minute, where engines typically began to overheat, the needles held steady. Lytle frowned, leaned closer, and barked for the test to continue. 5 minutes passed, then 10. The gauges refused to budge. The air flowed evenly through Tony's aluminum arteries, carrying the heat away like water through a perfectly balanced pipe. No fire, no smoke, just stable power. For the first time, Wright Field fell silent, not from failure, but from disbelief. By early May 1943, the tests at Wright Field had turned whispers into astonishment, yet astonishment alone could not break the barriers of military procedure. The Army Air Force's Engineering Division declared Tony Validore's pipe modification non-standard and unverified, citing lack of formal credentials and unauthorized fabrication methods. The same brass who praised his ingenuity privately condemned the deviation from official blueprints, fearful that approving a plumber's contraption would expose oversight failures within their own design bureaus. Tony listened quietly as a colonel read the rejection memo, the words "experimental anomaly" cutting sharper than any insult. Nevertheless, word spread among the B-29 maintenance crews stationed at training bases from Kansas to Georgia. Mechanics began replicating Tony's design using scrap tubing and salvaged aluminum ducts, calling it the Validore loop. Field reports trickled back to Dayton, showing that modified bombers consistently avoided overheating during prolonged ground tests. Within months, pilots flying prototype missions noted engines running cooler, with reduced cylinder failures and lower fire incidents. The evidence mounted faster than regulations could suppress it. Engineers bound by paperwork watched as unlicensed innovation began to outperform sanctioned design. Major Harold Lytle, torn between loyalty to protocol and belief in empirical proof, ordered an unofficial trial flight over the Great Miami River Valley. He assigned a modified B-29 equipped with Tony's bypass system to fly under maximum throttle for 2 consecutive hours. Tony, permitted to attend as an observer, stood beside the runway, his cap clenched in his hands as the aircraft thundered into the sky. For the first 20 minutes, the temperature readings held steady. Then the engines began running smoother, fuel consumption slightly dropping, exhaust flames fading into pale blue streams. The crew radioed confirmation: no overheating, no detonation, no trace of fire. When the bomber landed, Little approached Tony in silence, then removed his gloves, extending his hand in quiet acknowledgement. "You broke every rule," he admitted, "but you fixed the one thing none of us could." Still, official adoption remained forbidden until Washington reviewed the data. For Tony, it was another battle against invisible walls, one fought not with tools, but with persistence. His creation had proven itself beyond argument, yet the system that needed it most refused to listen. Bureaucracy had met innovation and recoiled. August 1944. The skies above Chengdu, China, glowed with the flicker of overworked engines as B-29s prepared for another high-altitude raid. Heat shimmered across the tarmac while ground crews fought exhaustion and fear, aware that one misfire could ignite thousands of gallons of aviation fuel. The Japanese held Burma and the Pacific Sea routes, forcing every spare part and drop of fuel to come by air over the Himalayas. Maintenance time was scarce, engine failures constant, and morale fading fast. Somewhere in that chaos, a young flight engineer named Sergeant Cole unrolled a grease-stained sketch labeled Validore Bypass Cooling. The drawing, copied from memory by a stateside mechanic, showed Tony S. crude, but elegant solution, redirecting airflow from the oil cooler through an auxiliary manifold to equalize temperature along the nacelle. Lacking official blueprints, the crew scavenged tubing from wrecked transports, welded makeshift joints, and sealed them with soap and prayer. Against every standing order, they installed the system on 3 B-29s before nightfall. The next morning, those bombers lifted off toward Yawata, the heart of Japan's industrial furnace. Midway across the China Sea, one formation climbed past 25,000 feet without a single temperature alarm. Engines that once coughed black smoke now purred with a steady hum. Enemy flak erupted from below, shrapnel ripping through the fuselage, yet not one engine flamed out from heat strain. Pilots reported unprecedented stability and smoother throttle control during return descent. When they landed, crews gathered in stunned disbelief. No fires, no seized pistons, and no casualties from overheating. News of the China fix raced through forward air bases faster than command could censor it. Crews began adopting the unauthorized pipe modification on their own, sharing instructions scrawled on ration boxes. Each day the same miracle repeated. Fewer fires, fewer failures, longer flights. Within a month, engine loss rates across the 58th Bomb Wing dropped by over 70%. Commanders couldn't ignore the pattern any longer. When General Curtis LeMay visited the theater, mechanics showed him a patched-together example of Tony S. system, still dripping oil, but running flawlessly under stress. LeMay, pragmatic and cold-eyed, simply nodded. "I don't care who built it," he said. "If it keeps my planes in the air, install it on every bird." In that single order, Tony's once ridiculed invention became standard practice, authorized at last by necessity, not by permission. By early 1945, the Validore cooling modification had quietly become an invisible standard across B-29 units from Guam to Tinian. Official manuals never mentioned its name, yet every flight crew knew its worth. Pilots trusted the curved aluminum tubes almost as much as their own wings, while mechanics treated the modification like sacred craftsmanship, passed through whispers. In less than 6 months, in-flight engine fires dropped by nearly 90%, saving thousands of airmen who otherwise would have perished above the Pacific. Still, in Cleveland, Tony Validore remained a ghost, an unacknowledged civilian whose design carried no official patent, no Navy letterhead, and no credit. At the Glenn L. Martin plant, where the first modified engines rolled out for mass retrofits, an internal memo deliberately omitted his name. The document cited anonymous field innovation inspired by maintenance observations. Tony received no royalty, no promotion, and no public notice. Instead, he continued repairing plumbing valves for a steel foundry, unaware that his midnight sketches had crossed oceans and shaped history. Only a few pilots knew the full story, passing his name like contraband between missions. One of them, Captain Howard Hawk Jensen, wrote in his logbook after a harrowing return from Iwo Jima that his engines ran cool as a Cleveland winter. His words later reached a stateside engineer who traced the expression back to a local mechanic, Validore. That same week, the War Department quietly requested technical clarification from the original modification team. But bureaucratic caution buried the correspondence beneath layers of classification and red tape. Tony's only acknowledgement came through an indirect letter sent by a friend stationed in Saipan, thanking him for saving more men than he'd ever meet. He pinned that letter above his workbench, its edges blackened by solder burns, a private reminder that his rejected idea had found its own justice in the skies. When the war ended months later, military engineers presented a report on enhanced airflow systems that credited no individual at all. Yet the curved pipes remained, small silver veins running through the heart of America's deadliest bomber. They were living proof that genius can emerge from anywhere, even the hands of a plumber who refused to believe experts always know best. Have you ever heard of the B-29 Superfortress? By 1945, this beast of a plane dominated the Pacific skies. But it wasn't always that way. Early on, the B-29 had a terrifying nickname, the Flying Furnace. Its powerful Wright R-3350 engines were notorious for overheating, leading to catastrophic fires and forcing crews to ditch their planes in the ocean. The promise of a game-changing long-range bomber was literally going up in smoke. But then, something changed. Suddenly, missions that once ended in disaster were reaching Tokyo, Osaka, and Nagoya with deadly precision. Air crews noticed a strange new calm. Their engines no longer screamed in protest during steep climbs. Oil temperatures, which used to spike dangerously in the tropical heat, remained stable. This newfound reliability wasn't just a minor improvement. It was a revolution. It allowed pilots to focus on their targets, not on whether their own plane was about to explode. What was the secret? It wasn't a radical new engine or some high-tech gadget. It was a humble piece of pipework, a simple bypass designed by a plumber from Cleveland named Tony Validore. His idea was almost ridiculously simple. He saw the engine's airflow problem not as a complex aerodynamic puzzle, but as a basic plumbing issue. He realized the rear cylinders weren't getting enough cool air, while the front ones were getting too much. So he designed a bypass pipe, a curved piece of aluminum that simply redistributed the airflow more evenly. When he first pitched it, engineers scoffed. His hand-drawn sketches, made with a carpenter's pencil on stained workshop paper, looked crude next to their polished blueprints. They called his idea ridiculous. But in the desperate calculus of war, even a ridiculous idea was worth a try. The results were staggering. At Guam's North Field, Colonel Paul Tibbets, yes, the future pilot of the Enola Gay, reviewed the flight data. Where once every 20 sorties risked a mechanical catastrophe, now 99 out of 100 B-29s with the modification returned home safely. His official report noted the change as stabilization due to improved cooling flow. That sterile, understated phrase masked a monumental achievement. Post-war data would later confirm that engine temperatures dropped by an average of 108 degrees Fahrenheit, and mid-air engine fires were reduced by an astonishing 90%. Validore's pipe had turned one of the most temperamental engines in aviation history into a dependable workhorse. This mechanical miracle transformed Allied strategy. Commanders could now plan missions deep into the heart of Japan without gambling on mass losses from engine failures. The B-29 became a true psychological weapon, a symbol of endurance and inevitability. On Saipan, a flight engineer named Master Sergeant John Bynum would tap on that same aluminum pipe with his wrench for good luck before every takeoff. He never knew the name of the man who designed it, but he credited that simple curve of metal with keeping his crew alive after flak ruptured their cylinder cooling fins. The pipe held, he wrote in his journal, and the temperature never rose. These quiet successes, multiplied across thousands of sorties, formed the unspoken backbone of victory in the Pacific. When Japan surrendered in August 1945, celebrations erupted across the world. But in Cleveland, Tony Validore stood silently beside a pile of scrap aluminum that had once built miracles. His name never made it into the official histories or onto memorial plaques. At a post-war symposium at Wright Field, his sketches were displayed, but few realized their humble origins. The military recorded his genius invention with the bland, anonymous title, Field Modification 2197, Auxiliary Air Distribution Bypass. The design became the property of the War Department, absorbed into the vast ocean of uncredited wartime innovations. But Tony's influence didn't just disappear. It rippled outwards, silently shaping the future of aviation. Engineers from Boeing, Consolidated, and Lockheed quietly incorporated his principles into post-war commercial airliners. The proportional airflow logic he sketched out with a pencil anticipated modern thermodynamic balancing techniques decades ahead of its time. Even the first generation of jet engines used heat distribution methods derived from his simple, intuitive solution. He returned home to his quiet life, fixing neighborhood water heaters with the same patience that had once saved bombers. When a neighbor asked what he did during the war, he just shrugged and said, "I just kept things cool." By the 1950s, as the jet age dawned, the B-29's early struggles were fading into bureaucratic archives. Hidden in those dusty files was a single handwritten note from a Wright Field engineer. Modification originated from civilian mechanic, Cleveland, Ohio, effective beyond expectation. It was the only official acknowledgement of his contribution. His design, replicated across entire bomber fleets, was standardized under the generic name Auxiliary Airflow Line. The man behind it was effectively erased. But his legacy lived on, invisibly, in the cooling efficiency of long-range reconnaissance planes and early jet bombers. Years later, a local newspaper ran a small retrospective on the war effort. Tony's name appeared once, misspelled and buried among other minor citations. He clipped the article, folded it, and placed it in an old cigar box along with his original sketches. History may have denied him fame, but his creation endured, flowing invisibly through every engine that stayed cool under fire. It's a powerful reminder that genius often wears work boots, not lab coats, and that sometimes the smallest, most overlooked ideas are the ones that truly bend the course of history. When Tony Validore passed away in 1968, his obituary mentioned only that he was a retired plumber and mechanical tinkerer. There were no military medals, no engineering awards, and no public ceremonies, just a few former mechanics who remembered his laughter, his grease-stained hands, and his relentless belief that nothing made by man was beyond repair. Yet his legacy existed in the invisible currents of air that coursed through every modern engine, from the B-29 Superfortress to the jetliners streaking across the post-war sky. His principle, that heat could be defeated through the balance of flow, not force, became an uncredited cornerstone of aviation reliability for generations to come. In aerospace design archives, engineers unknowingly referenced his concept through technical terms like pressure equalization manifold or thermal bypass routing, unaware that their origins traced back to one stubborn plumber who refused to surrender to failure. His drawings, still marked with coffee stains and margin notes in thick pencil, circulated quietly among young designers at Wright-Patterson Air Force Base, often labeled as Legacy Field Adaptation, 1943-44. They became the unsung blueprint behind America's transition from fragile machinery to enduring flight power. In Cleveland, the workshop where Tony had built his first bypass pipe eventually fell silent. His tools were sold off, his workbench dismantled, but the faint burn marks on the wooden floor remained, scars of creation, just as his invention had been born from crisis and flame. When aviation historians later traced the evolution of bomber cooling systems, they found no single official inventor, only the mysterious note referencing a civilian modification, highly effective. That anonymity became part of the legend, echoing through technical folklore as the Cleveland Fix. 80 years later, when aerospace museums restored surviving B-29s for flight, technicians found the bypass pipe still in place, its metal dulled but intact. They documented it as an original field modification, unaware they were touching the legacy of a man who had redefined resilience with nothing but instinct and stubborn faith. The story of Tony Validore reminds the world that progress often begins where expertise ends. and that sometimes it is not the engineers but the dreamers who keep the engines of history alive.